Hi students, hope you are doing well. In this video I am going to explain you standard hydrogen electrode and how it helps to find the E0 value of different metal electrode in their electrolytes. So first of all, let's discuss the schematic diagram of the SHE. Here you see there is a glass tube inside which one wire of copper is inserted, at the end of which platinum electrode is there, and whole this setup is immersed in the 1 molar HCl solution, and from the right side the hydrogen gas under 1 bar pressure is subjected inside this glass tube, and this standard hydrogen electrode can act both as anode as well as cathode. We know at anode oxidation take place, and code for oxidation is LEO, loss of electron oxidation. So this hydrogen releases 2 electron, loss is going on. Okay, this hydrogen gas coming from the right side, it loses 2 electron and converted into 2H plus ions. And when she act as cathode, then this hydrogen ion present in the aqueous medium coming from H plus ion, coming from dissociation or oxidation of hydrogen gas, this H plus ion then captures the electron which is present in the aqueous solution and convert into hydrogen. So you know at cathode reduction take place, GER, gain of electron is reduction. So this is the reduction process, and she is called as reduction, reversible electrode, I mean to say, because the anodic reaction is exactly reverse of the cathodic reaction. So this is the representation of SHE, and its standard oxidation as well as reduction taken as 0. In order to justify this, I am going to write the equation E0 cell is equal to E0 cathode minus E0 anode, and we know both the reactions are written over here, and if you try to find the overall reaction, you will find H plus ion will cancel out from H plus ion, hydrogen gas will cancel out from hydrogen gas, so net overall no new substance is formed. So E0 value for standard hydrogen electrode is taken as 0. This justifies the statement. So now we got to know why she is called as reversible electrode and how come its value of E0 becomes 0. Now the next step is to know how it helps to determine E0 value of different metal electrode in their electrolyte. To this, to understand, first you make you revise the concept of electrochemical series. We know that in electrochemical series the E0 value for the hydrogen is 0, just now we found out, and it is taken as a reference electrode. Okay, because the metal electrodes which lie below it have negative E0 value, and which lie above it has positive E0 value. And it is a thumb rule of electrochemical series that greater the negative E0 value, greater is the reducing power of that metal electrode. It means it will undergo oxidation. Got it? So the species which lie below in the series, it undergo oxidation, and the species which lie above in the electrochemical series, it undergoes reduction. It's a common rule that you should remember. Another thing, how we represent the electrochemical cell, to this to understand, you should understand this thing. You see, this is the symbol of the salt bridge. I'm just taking one example of Daniel cell. This is the most common form of the electrochemical cell. In this, zinc ion change into zinc plus ion and copper ion change into copper. Okay, so I'm just not going into the detail of that. I'm just telling you on the left side oxidation takes place, and oxidation takes place at anode, and sign of electrode here is negative. To make it remember, you can make your hands like this: O for oxidation, A for anode, and this for negative, and I have taken the left hand, so this is on the left side. So reverse happen on the right side. So like this, you can remember which side to write oxidation, which side to write reduction. Okay, now I'm going to explain you how she helps to determine the E0 value of different metal electrode. Let's first of all take the example to detect the E0 value of copper electrode in its electrolyte. So from the series of electrochemical, we know that copper electrode lie above the standard hydrogen electrode. So if it is lying above, means it is undergoing reduction. So she will be taken on the left side, and copper electrode will taken on the right side. Now from the formula of E naught cell is equal to E naught cathode minus E naught anode, okay, we will find and substitute the value of E naught cell. Okay, when we connect She with the copper electrode and its electrolyte, from the voltmeter we find the value 0.34 volt. Okay, now this value we have to find, and its value we know well. Okay, so after simplifying the equation and calculating, we find that E naught value for the copper electrode is 0.34 volt. Okay, now I'll take an example of the E naught. We'll find E naught of that metal electrode which lie below the hydrogen in electrochemical series. So one such example is zinc. Now since it lie on below the hydrogen, so it should undergo oxidation, and we know oxidation takes place, is placed on the oxidation half is placed on the left side. So the zinc electrode and its electrolyte, this cell we are taking on the left side, and She we are placing on the right side. We are connecting with the salt bridge and with the help of voltmeter, and now we will write the equation E naught cell is equal to E naught cathode minus E naught anode, and after connecting She with the zinc cell, we find the voltage to be 0.76 volt, okay, from the voltmeter. Okay, now the value of She we know it is 0, and value of E naught we can find, and it comes out to be minus 0.76 volt. Like this, for any metal electrode, by taking the standard hydrogen electrode as a reference, we can find the standard electrode potential of any metal electrode and its electrolyte. I hope it was helpful. If you have any questions or the queries or any of the demands, you can please put it in the comment section below. I'll keep making such useful videos as per your demand in future also. Till then, keep rocking. Bye bye.